How's it going, everyone? Vlad here, and today we're going to be talking about the Copia Industrial DevOps 2025 report. And I believe it is a very important and interesting topic because it touches both the OT as well as the IT spaces and manufacturing as a whole. Now, as some of you may know, I've spent a lot of my career on the OT side, working for manufacturers, working for systems integrators, consulting in various capacities on the engineering and management sides. That being said, I've also spent some of my years in the IT startup space where we basically built a competitor to Datadog, New Relic, Splunk on the DevOps side. So I believe to be fairly uniquely positioned to be able to talk to some of this data. And of course, I trust the guys at Copia to have done their research. My goal is simply to maybe add a little bit of information and context, maybe give some of my opinions based on some of my experience, and ultimately start a conversation and discussion in a space that I still believe to be relatively new, which is the industrial DevOps as well as ICS, or the industrial cybersecurity, which I think is extremely relevant and even more so in the age of AI. So it is a free report that you can obtain on your own, and it is 48 pages long. So we're going to skim through some of these sections. I don't believe that we need to read through every single statement. That being said, here is a mention from Adam Gluck, who is the CEO of Copia. And basically, there's going to be key takeaways that I believe we need to keep in mind as we go through this. So number one is the C-suite respondents report the highest average cost of downtime at $4.29 million per hour. Downtime is attributed to industrial code remains significant at 45%. Cybersecurity breaches are the number one cause of unplanned downtime for the second year in a row. 92% are invested or plan to invest in industrial DevOps within the next 11 months. And 89% agree that integrating AI into the industrial DevOps platforms will unlock new levels of efficiency, productivity, and innovation. So as I've mentioned in a couple of my posts, I believe that I agree with the data that is basically mentioned here. What I think is important also to understand as you're reading some of this information is that it requires a lot of context. So obviously there's going to be nuances and differences depending on the vertical that the manufacturers are in. This information may or may not be presented further in the report. I have not gone through all the information, but basically, as you're looking at some of these numbers and you're maybe reflecting on your own facility or your own operations, it is important to keep in mind that it might be different in verticals, in the size of the organizations, and of course, how complex your architecture is. With that in mind, my other opinion is, of course, AI still remains top of mind for many executives and many employees in a lot of these companies. However, I believe that the investment is rarely going to pay off on the AI side immediately when it comes to operations, and it's going to be a bit more critical to invest in the architecture as well as the infrastructure and DevOps before getting into the AI specifically. But that is a conversation for another time. So here's the welcome message to the second annual State of Industrial DevOps report. I've talked extensively about the previous one last year, so we're going to read through this. Building on the findings of our inaugural report, the second annual State of Industrial DevOps report tracks the continued evolution and adoption of industrial DevOps across the industrial landscape. While benchmarking remains the core focus, this year's report also includes a new dimension based on seniority to provide a richer understanding of how perspectives on challenges, priorities, and solutions differ across organizational levels. Increased connectivity, the proliferation of smart devices, and the ongoing shift towards software-defined operations present immense opportunities, but also significant challenges related to OT cybersecurity, adoption of AI, and impact on the workforce, just to name a few. The data included in this report reveals the industrial DevOps offers a critical bridge between information technology, IT, and operational technology, OT, enabling better collaboration, governance, and security in the management of industrial code that powers modern production. I agree with all of these statements. I think it is extremely important in this time to be having these conversations. I've had multiple projects arise as a result of cybersecurity concerns, as a result of increased premiums on some of those insurances. So extremely important. Table of contents. There's going to be a lot of different pages here. Executive summary. So the cost of downtime escalates with seniority. The most compelling finding is that the perceived financial and strategic impact of downtime increases significantly with seniority. C-suite executives view operational disruptions as a far more costly and enterprise-threatening issue than their operational managers do, leading to different levels of urgency and investment priorities. So that is a very interesting finding in and of itself, because ultimately that tells me that managers are prioritizing a different set of initiatives over executives. And so at this point, we haven't seen the data if it's VPs or directors versus management on the plant floor versus your C-suite type of people. But ultimately, this tells me that maybe there's a disagreement on what needs to be prioritized based on people closer to some of those problems and people who are maybe a little bit further away from the day-to-day operations. Divergent views on the risk and root cause. This perception gap extends to the root cause of downtime. Senior leaders point to systematic issues, the industrial code, like the industrial code and cybersecurity, as primary drivers, whereas managers on the floor are more focused on immediate hardware failures and human error. This creates a fundamental disagreement on where to focus resources for remediation. And this is a conversation I've been to in many different plants. So the people on the plant floor will disagree with the corporate team what some of these issues are and how to allocate capital and resources to some of these initiatives. And I couldn't tell you that there is going to be a single answer. I think it's going to be extremely nuanced. It's going to be very interesting for me to see some of this information. But basically, obviously, there is going to be a answer that should be more tailored to your specific organization. But basically, there should be a better answer that is tailored for your specific organization based on multiple different variables. We also have misaligned priorities on the AI and security. While enthusiasm for AI is universal, leaders are focused on mitigating strategic risks like data security, while managers prioritize tactical operational efficiencies. Similarly, OT cybersecurity is a top-tier concern for the C-suite, but a much lower priority for managers, exposing a potential blind spot in organizational defense. I would say that this is something I would expect. So your C-suite and even vice presidents are going to be a lot more strategic in nature, while your managers to director type of roles are going to be a lot more pragmatic on what needs to be done. And I'm not surprised, or I guess I'm surprised to see that this is maybe a misalignment of priorities, because usually the strategy for a business is going to trickle down from the C-suite into the management type of roles that are going to be executing said strategy. So maybe there is a difference of opinions, but I would expect there to be a cohesive story when it comes to the strategy and the operational activities taken by the management teams. So here we have the DevOps Imperative in 2025. The industry report from Copia Automation in association with Sapia Research is based on a survey of 200 executives and senior managers actively involved in their organization, operational technology, and industrial automation strategies. So very important to keep in mind as well. Here's the pool of people that has been part of this extensive survey. Participants span C-suite 46%, SVP, VP, and head of department 16%, director 22%, and manager 16% in terms of the role breakdown. So here you have the full set of data that has been basically pulled. I am surprised to see that there is no mention in terms of company size, which I think is obviously relevant. Actually, there is an annual revenue proxy that you can probably use for that specific metric. So that's going to be on the left-hand side. So this is the annual revenue of the company. As you can see, we have a lot of fairly large, so 15 billion plus is your 39%. Then you have 24% of 1 to 15 billion. And 27%, $300 to $1 billion of annual revenue. So these are sizable companies. These are not your maybe small to medium manufacturers. So keep that in mind as we read through this. But it also makes sense in my conversations when we're talking about DevOps, when we're talking about IT, OT architectures, when we're talking about having some of these more advanced best practices on the plant floor. It's usually not going to be something considered or even critically important for the small to medium organizations, depending on where they currently stand. Industry also very interesting in terms of data. As we can see here, 21% is retail. I would be very interested to understand what the retail manufacturing or industry is. There's going to be the high tech or electronics and semiconductor space, 19%. We then have food and beverage, 17%. I do a lot of work in food and beverage, pharma, and CPG type of industries, 14% transportation and warehousing, 11% in aerospace, and then the remainder, 20 or so percent, is going to be in all others, so oil and gas, chemicals. So again, it is important as you read through this set of data to keep those numbers in mind because it may or may not be relevant for your specific size and or industry. Let's try to move a little bit further. So industrial DevOps, how did we get here and where are we going? So this is going to be a bit of a historical piece. I think it's definitely relevant if you don't understand the basics of DevOps. I think this is an excellent graphic, so let's read through it. To unite IT and OT, it's important to understand their technology stacks because in essence, they are speaking two different languages. I would agree with that. IT speaks a language of dynamic scalability and rapid deployment, fluid and cloud containers, and CI/CD pipelines. Speaks a language of varying reliability and physical safety rooted in the deterministic logic of PLCs and HMIs. I would say that a lot of the folks on the OT side are starting to better understand IT requirements, especially in 2025, and vice versa. I have some clients where the director is basically hiring software engineers to manage IT, and he is training them on the gaps of the OT space. Obviously, that is not true for everybody out there. So there is the sentiment of IT and OT convergence, but that is a whole other debate and conversation. Without a universal translator, requests for more agility from IT can sound like more risk to OT. Industrial DevOps acts as the translator, creating a shared vocabulary and tool set that allows both teams to work towards the common goals of efficiency and security. I am surprised, I would say, by that definition of DevOps. I don't believe that DevOps is the translator. I believe that DevOps is a set of tools and methodologies that makes it possible to use some of the traditionally IT types of tools and technologies and approaches more on the OT side. And you can obviously draw your own conclusions, but I would probably change that definition a little bit. But here we have on the right-hand side the DevOps tech stacks, and you see very prominent names of different companies in different layers of the organizations. So we're not going to spend a lot of time on all of them, but basically you have your OT and the IT side. Of course, you have Copia in the backup and disaster recovery. There's going to be a couple more companies that are positioned next to Copia in that space. That being said, we see also the cybersecurity players, so the Clarity, the Dragos, the Zombie Networks, with which I'm fairly familiar with. Obviously, we have the IT space. Once again, I named a couple of those names a little bit earlier, but we see Splunk, we see Rubrik, we see Red Hat, Microsoft, Snowflake, and Okta, and a couple of others on the different layers. Let's keep on moving on. I think this is an excellent representation for the OT and IT side. It is basically derived from the very commonly known graphic on the DevOps side that is a little bit simpler to understand in software. But here, of course, we have the complexity, as explained, of the real manufacturing environment. So I think it captures quite that there is not a simple build, test, and simply redeploy type of a software of an environment. It is a little bit more complex than that. So industrial code lifecycle management, moving from acceptance to action. So we have today's reality. I'm assuming this is some kind of a case study or maybe example of what is possible. So today's reality, we have 18 locations, 2,079 PLCs, 2,114 associated devices. I'm assuming it's devices on the network, 28 controls engineers, 75 technicians, PLC vendors in use, Siemens 60%, Rockwell 30%, Codesys 5%, and Ladder Logic 98%. I would have liked to see a little bit more information about what exactly is this case study talking about. Is this a automotive plant? I would assume based on the heavy presence of Siemens in this specific facility, this is some kind of a European 18 location type of a manufacturer, because as in North America, Rockwell is quite a much heavier presence. But again, without further information, it is very difficult to draw any tangible conclusions. So ultimately, what they're saying is that there's a lot of manual backups and ad hoc version control. I would be very surprised by this. I still see a lot of this in less automated facilities, but I would hopefully see that in some of the maybe top 3 or top 5 locations for this specific manufacturer, they are using either the Siemens or the Rockwell solution to be able to back up some of their code. Of course, it's not necessarily going to be Git based, but it will be doing a better job than some manual backups, although I would not be entirely surprised. Third-party issues, some auto backups, but primarily version control. That's exactly what I just mentioned. OT cybersecurity vulnerability, incomplete asset inventories, unknown code changes, outdated backups, limited or no recovery plan. I see this all the time, so I am completely agreeing, and I'm assuming that this is the case in this specific facility. So of course we can make all of that better, and there's going to be a set of different possibilities on each one of those fronts. Next, we have downtime in 2025, the persistent and evolving trillion-dollar challenge. So as many of downtime is by far the hardest problem to solve for most manufacturers. A lot of them are fighting for the 0.1% if they're large enough, and many of them are fighting for the 5 to 10% improvements if they are smaller and the gains are actually there. So obviously downtime is a very discussed topic when it comes to manufacturing and industrial automation. So here we have a graphic of the significant cost of stoppages. The C-suite is in a different realm. So divergence on the cost of downtime remains a critical finding, with C-suite executive reporting 50% higher than directors and managers. And so this number is very, I want to say, showing, right? And what it is showing, to me at least, is not the fact that there is a difference in downtime between these different groups. What is really surprising to see is that it seems that there's maybe a misalignment of tools and data collection that allows you to confidently say, what is this downtime actually attributed to? So the way it is worded, and maybe I'm misunderstanding this, but it seems that the C-suite executives are attributing a much higher cost to the downtime of their facilities than their managers. And so again, to me, this reveals that either someone is not reporting the right data, or the data is simply not there to maybe show some of these outages, or there's maybe a layer of misinformation when it comes between those groups. But I would hope that in the same organization, when you're presenting that data from the plant floor to the VPs and to the C-suite, that the data is going to be exactly the same. So I'm a little bit surprised that there's almost I don't want to say a full 50%, but at least a good 40% difference between your management team and the C-suite. Your downtime problem, look to your industrial code. Industrial code remains a major factor in operational disruptions, as 45% of total downtime is attributed to issues related to industrial code. How is this possible? Deeper in the data, we see that the size and complexity is crippling large organizations within their operational technology environments. The larger organization, 15 plus billion in revenue, say that industrial code factors in a whopping 66% of downtime incidents. As we look at the highest amount of PLCs, 60% average duration of downtime, 65%, and highest cost per hour of downtime, 70%. Based on the data, it can be inferred that complexity extends downtime incidents and places a greater attribution to industrial code management, testing, and deployment. An additional divide here is by seniority, with C-suite attributing 52% of downtime to industrial code versus 30% cited by managers. I am very surprised to hear this type of information, because if you're interviewing people from the same company, I would hope that they would report the same percentages. This data is not created in the void. Usually this data is either pulled by the numbers from the downtime of your lines, or the data is pulled by different systems at the SCADA and MES layers. So I'm surprised to see such a wide gap between C-suite as well as management. That being said, I'm also surprised to see that the more automated the space is, obviously more things in theory can fail, but I would assume that it's not because of code changes or industrial code problems. So I would hope maybe next year, or maybe through the data that Copia has, it would be interesting to see what kind of actual root cause was found to be for when we're saying there's downtime as a result of the industrial code. Is it because we're unable to deliver machines with the right information on time? Is it because we're making changes? Is it because we're running R&D projects? Is it because someone's changing the code remotely on the internal side, on the external side? I think they've also mixed in cybersecurity, maybe in some of this information. So it is not extremely clear to me why that number is so high for the larger organizations. I would assume that they can keep a tighter leash, so to speak, on their industrial software. Cybersecurity issues increase unplanned downtime. For the second year in a row, cybersecurity ranked as the #1 cause of unplanned downtime, although this year it is tied with hardware malfunction and code software issues. While it is not surprising to see these at the top causes, it is surprising to see the extremely different perspectives of managers versus C-suite executives, ranking cybersecurity at 22% versus 45% respectively. So once again, I am very surprised to see these numbers as they themselves say. I would be very interested in seeing how these percentages were actually, I guess, obtained and why there is such a gap between the managers as well as the C-suite level executives. So cybersecurity is definitely a huge threat and a huge concern in many different environments, especially now that we're pulling more data, we're automating with equipment and hardware that is more and more connected, and we're looking to synthesize a lot of that data from the plant floor into meaningful reports and ultimately actionable projects and figure out where can we allocate capital best. That being said, again, surprised to understand why they're mentioning hardware malfunction and coding or software issues. Obviously, there have been multiple attacks of ransomware, but I would, again, be very curious to see a breakdown of what a hardware malfunction is, as well as the coding and software issues on this specific side. There's an interesting quote from Clarity. They say that security leaders can no longer afford to treat OT as the black box they don't understand or believe in mythical air gaps from the internet protecting them from any potential threat. Threat actors are investing time and resources into targeting and exploitation of weaknesses in OT. I think it's definitely true. Causes of technical debt, quick fixes versus value fixes. While downtime numbers vary, every organization can agree on one thing: the less downtime, the better, but at what cost? This high number of ad hoc fixes year over year is a signal that organizations leaning into the quick fix are increasing their technical debt by not addressing the core problem. I would agree 100% because I have myself experienced misallocation of capital. I think that you need to, if you're creating a strategy for optimizing your OT and IT environments for that matter, you need to be very knowledgeable in those spaces and you need to understand how to prioritize your budget and resources. Perception versus reality, does ad hoc fix follow-up really happen? This year's survey added a new question to understand how frequently these ad hoc fixes receive follow-up. When asked how often respondents followed up on a fix, the problem addressed by ad hoc fix, 7% said that they do it every time, and another 54% said most of the time. This is surprising when looking at another data like the time to recover from downtime incidents, 28 hours, time spent debugging code and each month, 488 hours, and percent of time spent remediating cybersecurity issues, 69%. So frequency of follow-up to permanently fix ad hoc fix addressed. And the joke in manufacturing is that everything that has been basically patched and that needs to be updated to a permanent solution is going to remain on the temporary fix. So this data seems to indicate that most people are not going to, and I would assume that a lot of people will not be completely honest to a question like this. And so I would actually expect these numbers to be a lot lower. So a temporary fix or an ad hoc fix is probably not going to be remediated down the line if it's put in place, at least in my experience. Compounding code and cascading fixes. With the increase of devices in operational technology or IT environments, the code that runs those devices has triggered a compounding effect. Once an industrial code downtime event happens, the time to recover, 28 hours, shines a light on the reality of industrial code management practices and the barrier it poses to rapid recovery. Again, I think I have some opinions and probably I guess, opinions on how this needs to be addressed, how this needs to be solved. A lot of times, I think high-level data can be misrepresentative of what actually happens on the plant floor. So my view is when there is an incident that is going to take 28 hours to fix, you're going to not only find problems in how your software is stored and how you've been managing documents, but you're also going to find a ton of obsolescence. You're going to find a lot of equipment for which there hasn't been any software stored. And I've had many of these projects over the years where it's not necessarily the PLC the problem, it's the servo drive that hasn't been updated in years. And now your only option is to buy a laptop with a parallel port and basically give it to the engineers with, to some extent, an unlicensed piece of software so they can figure out how to get into that. And that will extend your downtime. So I think that the data to some extent makes sense, but the devil is always in the details. So I would be very curious to see as to what these actual breakdowns or triggers have been to get to this information. So a quick win adds value, a quick fix add so a quick win adds value, a quick fix adds time. Invest in solutions that enhance, not just extend. This is by Jeff Winter. So obviously this is a good quote. I don't believe in shortcuts. If you're looking to get shortcuts from your employees, usually it doesn't last very long. And I think that you need to be building a solid foundation in your OT, in your IT environments. And typically you can almost feel the environments where a lot of shortcuts have been taken. So they are basically paying for the technical debt over the years versus environments that maybe took a little bit longer to establish that foundation and found the right fix for the problem before moving on to something else. 50% perception gap on the cost of downtime is critical. If those holding the purse strings see a much larger fire, their willingness to invest in comprehensive solutions like industrial DevOps will differ significantly from those who, while still seeing a costly problem, might underestimate its total strategic impact. Adam Gluck, CEO and founder of Copia Automation. So obviously, when it comes to sales or when it comes to maybe having conversations with some of these different stakeholders, it's important to understand what they put more importance on. And if they are in the C-suite or director or VP levels, based on this information, they are a lot more concerned with cybersecurity and software-based outages, and a bit less so if they're at the management level. So keep that in mind as you're having those conversations, maybe on the sales side or looking to deploy some of the platforms. Redefining the plant floor, the impact of AI and cybersecurity on OT. So I'm not going to spend a whole lot of time on this because like I said a little bit earlier in this conversation, I think that AI is extremely relevant, and I've actually spent a lot of time myself building my skill set on Claude Code and Cursor and OpenAI and all of the tools, but I believe that their application, at least for the customers that I'm speaking with, are going to be limited on the plant floor and are going to be mostly impactful when it comes to other applications. And as we build a foundation, it might change, but for now, I think there are other priorities for the manufacturers that I'm speaking with, at least. While leaders are optimistic about AI, their enthusiasm is dwarfed by the scale and risk they now face. The modern plant floor is sprawling digital ecosystem with the average enterprise organization managing over 2,000 PLCs and another 2,100 associated devices like cameras, sensors, and drives. So I guess this adds some more context to the case study that was presented to us earlier, with the number of nearly doubling every 5 years, according to IoT Analytics. Again, not sure about the data. The attack surface is expanding at an unmanageable rate. This is why data security and privacy for 80% is the top concern in AI adoption. It's no longer a theoretical risk. It is the mathematical certainty of trying to secure thousands of interconnected points of failure. I 100% agree with this. So I think that despite, or I guess regardless if you're looking to use AI or if you're looking to use data or if you're simply looking to deploy better network architecture, you will need to address the concern with cybersecurity. I think that for me, the point that still is a little bit debatable is whether or not you can actually use AI in your current state, or if you should be prioritizing cybersecurity and some of your architecture and infrastructure before you even get there within maybe a couple of years. Manual oversight is obsolete, demanding modern systems for cyber defense. So in an environment with over 4,000 devices from an average of 6 different PLC vendors, manual asset tracking and security oversight is no longer feasible. 100% agree with this. AI-driven version control with change detection and anomaly alerts. I don't believe that this needs to be AI-driven version control. You should be able to do that with normal tools. Git-based software has been able to do this for a few decades, so I'm not exactly sure what we're using AI here. It is impossible for human teams to manually monitor every code change across thousands of PLCs or vet every new device. They need intelligent systems to act as a vigilant, automated guardian that can spot a single unauthorized change or a new vulnerability across a complex multi-vendor landscape. This is a very surprising statement to see. I've been in environments that had thousands, hundreds or thousands of PLCs per plant, and basically you were not allowed to make those code changes. So this is a very surprising statement for me to read. I've been in environments with hundreds of PLCs per plants, per area even, and so you were not allowed to make those changes or any software changes whatsoever without prior approval or explicit permission from some of your managers or supervisors. So I'm a little bit, and I know this is different depending on the plants and environments. I'm a little bit surprised that there is that little oversight or perceived oversight in how these systems are deployed or changed. I've obviously seen plants where those changes are made by engineers or techs looking to troubleshoot or looking to figure out certain problems, but I would say that is the exception, not the rule, especially in large businesses. So they need intelligent systems to act as a vigilant, automated guardian that can spot a single unauthorized change. Once again, I think that I've not seen where unauthorized changes were made by bad actors. I would argue that it's more often an engineer remoting in or you giving access to perhaps a third party that was working on that equipment that is making changes that you're not necessarily blocking or overseeing. I would say that there's multiple methods of going about restricting such access via access controls or permission-based type of user monitoring. So yeah, I'm not exactly sure where AI comes in, but obviously it can monitor changes that have been made and the networks, and there's going to be multiple tools on that side. This isn't just a feature request, it is a fundamental requirement for operating security at scale. I would agree. I would say that as soon as you reach a certain size, you can no longer afford to just make ad hoc changes on your plant floor. So you need to be establishing a business, I would say process, establishing a culture that we're not going to make ad hoc changes. Everything needs to be documented, and your engineers and technicians need to behave as such. The integrity paradox, distrusting the tools you need the most. So the challenge of securing the plant floor is managing or is magnified by its complexity in dangerously fragmented OT space. And this fuels the top concerns around AI, the reliability of its algorithms, and a fundamental lack of trust in its models. If a human engineer struggles to master this complexity, how can a single AI be trusted to do so without error? And yet, herein lies the integrity paradox. Despite this deep-seated concern, teams are simultaneously demanding AI features that require an intimate understanding of their most critical systems. A remarkable 40% want AI for real-time code analysis, and 39% seek AI-driven optimization of PLC logic. They are asking AI not just to stand guard at the perimeter, but to enter the inner sanctum and actively improve core production code. This is, again, very surprising for me to see. I would be very concerned if the current engineering teams are looking to optimize code, at least that I've seen in production in current plants using AI. And the reason why I say that is on the software side, there have been huge repositories of code. So you are able to query AI, and it's going to obviously pull data from existing sources that it has scanned multiple times. It has a vast amount of answers on Stack Overflow and others that have seemingly declined in popularity, but it has been able to learn how to build code that actually makes sense. In the industrial space, I would argue our domain of knowledge is much smaller. It is probably a single percentage point, if not less than that, in for our space. And so it is extremely difficult at this stage to program using AI in the industrial space. It is not completely impossible. It is definitely there. But to say that they're looking for AI-driven optimization of your line PLCs is very difficult for me, I guess, to conceptualize given on my current knowledge of AI and our OT space. This reveals that the crisis of trust is not a wholesale rejection of AI, but urgent demand for trustworthy AI. One that is transparent, reliable, and proven to master the multi-vendor reality of the modern plant floor. I believe that the disconnect, and I think if we take a step back and if we think about AI building software code for a mobile application per se, if I'm a mobile application that's going to be, for example, a network, a social network, then you have millions, if not in certain cases, billions of users. So if I build a tool that I can then, or that I want to then test, I can send it to a small percentage of my users. And it becomes very easy and very quick to understand what fails. And this is canary testing. This is basically a deployment to a very small subset of your users to understand the behavior. In the manufacturing space, you don't necessarily have that capability. You cannot simply push your code just to see if AI has done a good job, because you're going to, number one, impact real mechanical systems. So you have a lot more guardrails usually built in by the electrical and process engineering that has been done on those machines that is not always documented or understood or even comprehensive to AI without full context of, let's say, your drawings, your schematics, your assessments. So it is extremely difficult to demand quote unquote trustworthy AI, because at this stage, I don't believe that you can feed the context necessary for AI to be quote unquote trustworthy or to some extent even useful. So it's going to be able to analyze your code. And obviously, if it's ladder logic, it's going to be a little bit more difficult, but it will analyze the code and maybe do its best based on its knowledge. But I would be extremely cautious with releasing it, so to speak, into the real production environments in the current day and age. Drowning in data, find a threat within. With thousands of devices generating millions of data points, the biggest security threat is no longer just an external attacker. It is critical, even getting lost in the noise, which can enable the infiltration across your operational technology OT environment. An accidental misconfiguration by an untrained employee, a major concern cited as lack of skilled personnel, 27%, is nearly impossible to find in a sea of routine alerts. This is definitely something I agree with. Every single plant that I go to is looking for electricians, is looking for technicians, is looking for control systems engineers, and there's definitely still a lack of skilled labor in our space. I have some opinions as to why that is, but basically I agree that this percentage seems about right. This is the new reality of internal risk. A single line of flawed code on one of the 2000 PLCs can halt the production or open an external door to your secure quote unquote environment, but finding it is like searching for a needle in a haystack. This makes AI powered anomaly detection indispensable. It provides the only practical way to filter that noise, instantly flagging the one event that deviates from the established baseline, whether it's malicious instruction or a costly human error. I'm, again, very surprised to read this to some extent, saying that a single line of flawed code on one of the PLCs can halt production definitely makes sense. Or it says, or open an external door to your secure environment. Again, I don't think that it's as easy as that based on, again, PLC programming. Obviously, you can set up messaging that's going to maybe send some data outside, and maybe there's going to be an attacker that will figure out what or which PLC is sending that information. But we have used firewalls and network segmentation to protect against this for a number of years. I am not exactly sure what AI-powered anomaly detection indispensable or what makes it indispensable. Obviously, it helps some of those prevention methodologies, but I'm not sure it's going to be the holy grail when it comes to cybersecurity. I think it's going to be just another tool that helps us better protect against attackers. And if you know anything about cybersecurity or the ICS space, it's not necessarily the ability to block everything. It's the ability to stop the attack for as long as it needs to, so that you could prevent the blast radius to be greater than anticipated. So it's not a question of preventing everything. It's about being able to secure as much as you can and be able to figure out where those changes are so that you could remedy the problem. And again, I'm not sure why it's AI powered. You can use the Copia solution for Git-based version control. So maybe AI is parsing some of that information, but again, the confidence paradox, high confidence masks hidden risk. Despite the massive scale and complexity of the modern OT environment, a remarkable 82% of organizations are very or extremely confident in the accuracy of their assessed asset inventories. I am very surprised to hear that, because every time that I show up to a facility to do an assessment or to do a DTMA, usually most of them cannot answer the most fundamental question of what does your network look like? How many panels do you have? What do you actually have inside of those panels? So it says 82% are highly confident in their ability to recover from a major cyber attack using code backups. Again, surprised to see that number, because usually that is very far from being the case. While the confidence it encourages, it presents a potential paradox, particularly when only 50% of organizations believe that cybersecurity between IT and OT teams is very effective. Is this confidence justified, or does it mask underlying risk? I would argue it masks underlying risks. Like I said, every almost facility that I visit is incapable of giving me the answers as to what they have in terms of industrial automation assets. They're unable to answer the questions of what kind of assets they have, what kind of vulnerabilities those assets have. Many factories still use PLC 5s, Slick 505s, or even 503s or 501s, depending on the protocol. Many of them are still using Windows Server 2002 or running RS View 32 on a Windows 98 or Windows XP machine that has not been supported for many years. Integrating code, security, and operations, it is clear that siloed approaches where cybersecurity, code management, and operations exist in separate spheres are no longer seen as viable in face of modern threats. Sure, the industry is no longer just identifying problems, it is explicitly asking for the solution. I believe that is true. The more organizations use both industry-adopted standards and ICS-specific threat intelligence, the more mature their overall cyber capabilities are. I would agree. Tipping point, how industrial DevOps is becoming an industry standard. The overwhelming mandate for industrial DevOps. Faced with the risks of a fragmented and insecure operational landscape, the industry is not just showing interest in a new solution, it is demanding it. 90% of industrial professionals agree with their team would directly benefit from using, and it looks like there's a typo there, industrial DevOps technology and practices. 20% of organizations have advanced access controls, but 13% still rely on shared credential. This is a big problem, right? So obviously, a lot of companies can benefit from a better DevOps posture. And whether or not you adopt some of these AI tools, I think to some extent is maybe a question for you. But ultimately, you need to take the steps necessary to have the bare fundamentals or minimums in place, of which there aren't many based on my experience in different manufacturers. The modern plant floor is drowning in complexity. 13 different software packages, 44% use IT version control systems, 40 still rely on manual spreadsheets. This is definitely the case. I would agree with what is said here. I would honestly think that percentage is higher in small to medium organizations. A further 27% admit to informal ad hoc savings of files on personal or local drives. I see this all the time. I think that the reality between IT and OT is so vast that it is even difficult for me to sometimes explain to IT that in order to run based on their policies, the OT teams need to cut corners to figure out how to keep production going. And I'll give one example or a story of this because I think it is extremely relevant. And so basically, although I don't necessarily agree with the practice of blocking all ports and all installations on a laptop, this is usually considered best practice on the IT side, right? So if you give an employee or an engineer a brand new laptop, you're not going to let them just go anywhere on the web, install whatever software they need. However, this becomes a problem on the OT side because a lot of our systems still rely on, I would want to say, very obsolete technologies, especially when it comes to software. So I've mentioned a little bit earlier, there was a case with a specific drive where naturally you needed to be able to communicate to that drive via a parallel port. And first of all, obviously the technicians and engineers did not have a laptop with a parallel port, but also number two, they're unable to even install the drivers for that parallel port to work. And that drive had no way of communicating to the network on which you could, let's say on a server, install that specific software. Long story short, when the IT gives you that laptop, the operational team or the maintenance team in that specific instance would be unable to restore production via the laptop that was given to them by the company. So to the IT surprise, what the OT team is going to have to do is go to Best Buy or go on Amazon or eBay, purchase a 30-year-old laptop, connect it to the network, get the drivers, and those drivers, I've seen the documentation, sometimes come on diskettes, but they're going to be downloaded from a very sketchy website. You're going to install the drivers, and then you're going to plug in to that specific drive. And you all are likely to see that laptop plugged into the infrastructure of the plant down the road when they need to fix something else that is not on the network. So all that to say is that although the plant teams were going to circumvent some of those rules or break some of those rules, it is also on the IT side to understand those nuances and provide them with the tools that they need to accomplish their job. And so if we look at this, again, 13 different software packages and 40% still rely on spreadsheets, I would expect that number to be higher, to be honest with you. And probably some of the respondents to the survey simply have not been to their plant floor in a long time. The adoption of industrial DevOps is no longer a future trend. It is a present-day reality that has reached a market tipping point. I would 100% agree with this. I think a lot of engineers, even on the OT side, are looking for better practices because they are being asked to, again, work with so many different software packages. They are being restricted by IT. They are looking to maybe bring in some of those initiatives to the plant floor. And so they don't have an option to basically make their life easier by bringing in some of the DevOps best practices. Business case, unpacking the drivers of investment. So 53% seek to improve basic PLC management version control. That is really good to hear. 51% aiming to integrate AI and automate code generation. Very interested in speaking to those individuals. 49% focused on ensuring reliable backups and disaster recovery. Excellent. That is a really good point. 46% looking to enhance OT security. 100%. I would hope that 51%, that 49%, I guess minus the AI, the 53%, the 49%, and the 46% to be higher. I think that there's a lot of opportunity there. This blend of stability, security, and innovation creates a compelling value proposition that justifies investment by promising to both protect current operations and accelerate future growth. Again, I could not agree more. A lot of my customers and a lot of my conversations have been as a result of some OT and IT vulnerabilities needing to be addressed. And if you establish a solid foundation on the networks, on the architecture, on your data collection, on your resiliency, it's going to pay dividends into the future, regardless if you're looking at AI or just data in general. Overcoming the final hurdle to transformation, the human factor. I'm a huge, I want to say, proponent of this because I've had, again, many conversations where I would show up to a facility and I could immediately tell based on the conversation with the engineering team and the plant team how well or how receptive they would be to some of these changes. And of course, it depends on multiple variables. And of course, this depends on many different variables. I think it is important to have the conversation with the plant that's going through some of these changes and their ability to basically adopt some of these technologies and tools and actually leverage them for the ROI that is being promised. So without the human being able to accomplish the job better, none of these tools actually matter. So with the technological need established and market momentum in full force, the greatest barrier to realizing the benefits of industrial DevOps is not budget or tools, it is people. 100% agreed. I've seen this many different times in my own personal career and experience. 43% of organizations cite change management resistance as the primary challenge to adoption. 100%, significantly higher than the competing priorities, 32%, or lack of budget, 26%. It's also crucial at this to point out the percent of organizations with no challenges has doubled year over year. So the percent of organizations with no challenges has doubled year over year. That is very interesting. No challenges has doubled. We have, and again, I'm not sure who's answering the survey. To say that we have no challenges, I would say is a bit maybe misleading, dishonest, maybe. I've yet to walk into a business that has no challenges. Very interesting. From firefighting to future building, the new focus of high-performing teams, preventing security issues, remediating them, learning new technologies, unplanned work and or rework. A lot of very interesting data. So again, if we look at the graph, so learning and adopting new technologies is going to be very often slash always. I would want to see who these individuals actually were, because even at the director and VP level and even management level, you can have a manager of IT or manager of OT, similarly VP of IT and OT. Obviously, their responses, I think, are going to be a little bit skewed. And I would argue that you need to be learning as much as you can, but also recognize the fact that when you're bringing in manufacturing or OT level equipment, you need to be a little bit more cautious when it comes to making some of these changes. And because some of these tools have brought to light, you're usually going to have investment cycles that are going to be quite longer in OT than in IT. So if we're looking at a software or a SaaS-based business, usually there's going to be turnover around 1 to 2 years in terms of different tools. You're evaluating your budgets, so you can question what you're using. On the OT side, it's going to be a little bit more challenging because a lot of that is still bound to your hardware and machine investments. And so usually those cycles are going to be between 7 and 10 years when it comes to your cap. So I'm a little bit surprised to see some of these responses, but like I said, I would assume some of it has to do with the lenient, or I guess the position of some of those individuals. Strategic imperative beyond opportunity to necessity. The evidence is conclusive. 90% mandate for a new approach. Industrial DevOps has moved beyond being an opportunity. Again, I would agree that there's a lot of different best practices that have been figured out on the IT side when it comes to DevOps that need to be applied to the OT side. In the era of increasing cyber threats and competitive pressure, relying on informal processes and fragmented tool chains is no longer a viable option. Once again, I fully agree that it is something of importance to everyone. And if you're even on the engineering side, you should be learning about these tools as much as you possibly can so that you could run POCs in your specific facility. Leveraging this report, a guide to benchmarking your industrial DevOps journey. So I'm assuming it's some kind of a short DTMA or digital transformation maturity assessment for the DevOps specifically. So why benchmark? Assess your current state against key metrics, identify perception gaps and misalignments, prioritize areas for improvement, tailor action plan, and monitor progress and iterate. I think this is a standard, I want to say, management approach. So obviously they explain as to why you would want to do this. Identify strengths and weaknesses, validate and challenge internal perceptions, build a data-driven business case, prioritize initiatives, foster internal alignment. I agree with all of these statements. This is what I use with most of my customers. Again, there's going to be a deeper breakdown of all of these points. So step 1, step 2, obviously understand downtime, resolution time, debug time, and a lot of the questions that I had asked throughout this prioritized area. Of course, high costs, high code attribution, cybersecurity, resolution time paradox, low adoption of specialized tools. 4, develop a tailored action plan, cross-functional communication, standardized metrics. There's going to be a lot of different areas here. I'm not going to spend time going through all of them. So these are going to be the demographics for the report. I would have wished, I guess, that I looked at them a little bit earlier. And we can see here immediately the decision makers for OT tech investment by department. Very interesting graph skewed towards IT. So if I understand this correctly, this is the decision makers within the organizations they have polled for this data. And as you can see, 71% of OT-based decisions are made by IT. And I obviously have an opinion on that side. We'll leave it at that for now. Very interesting report. So I definitely appreciate Copia putting this together. I think that we agree on probably 95% of the points made here, and probably disagree based on my at least experience on some of the AI obviously things and some of the necessities when it comes to these different tools. But regardless, if you haven't seen the report, this is free on their website, so highly encourage you to download it. And if you have different opinions, I think that the space is still relatively new. Very happy to have a conversation. Let me know what you think, and I will see you next time.